Okay, so in our previous class, we looked at closures and how we can implement closures in JavaScript and how useful closures are. And in this class, we're actually going to be looking at generators, iterators, and symbols. And under generators, iterators, and symbols, our aims and objectives for today is to actually understand the definition and concept of generators, iterators, and symbols, the syntax, the iterator protocol, the iterable protocol, the built-in and custom iterables. Last but not the least, we also understand the well-known symbols and how we can actually use them in JavaScript. So in order not to waste much of our time, let's begin. First on the list, we have generators. So what actually are generators? Let's look at the definition and concept, followed by the syntax. Then we'll look at the yield keyword. We proceed to the iterator protocol, and then we'll try to explore infinite sequences with generator functions. And last but not the least, under generators, we look at asynchronous generators. So first, what are generators? In JavaScript, a generator is a special function that can be paused and resumed during execution. It actually achieves this by using the yield keyword. When a generator function is executed, it does not complete its execution like a normal function. It pauses and resumes its execution using the yield keyword. So it can state and can be resumed later using the next method of the generator object. So when you call a generator function and you invoke the next method actually returns an object which contains a value and the done a value and the done property, which the done indicates if the generator function is done executing, if there's no value to be executed no more. And the concept behind generator functions is the pausing and resuming of function execution, yielding values, and iterators. Normally, generators use iterators under the hood. So pausing and resuming, like imagine a generator function as a recipe. You can follow the steps until you reach a yield statement. Once the yield statement is reached, it acts as a pause point where you can then resume execution later using the next method. Once the next method is called, it returns, when it encounters the yield statement, it returns an object with a value and the done. And when a next method is called, it continues execution to the next value in that function. So yielding values, you can actually yield a value in a generator function using the yield keyword, which is also a yield statement. So these yield values become the result when you use the generator in a loop or with other iterables. Yes, when you use a generator in a loop or other iterables, the yield keyword returns, when you use a yield keyword in the generator function, it returns a value at that particular moment. So iterators, generators are closely related to iterators. When you call a generator function, it returns a generator object. So which is an iterator. You can use this iterator within a loop to actually get the values of that generator function. So without talking too much, let's try to see how generator functions can be implemented. And for iterators, later in this class, we will look at what iterators are, what iterables are, and what actually we can use an iterators to do in JavaScript. Okay, so let's give a simple example here to understand what exactly generator functions are, what their syntax, and how we can implement them in JavaScript. So let me zoom in a bit. Okay. So in a regular function, let's assume you want to declare a regular function that generate numbers. What you just start with a function keyword, or if you're using arrow functions, you declare a variable number generators and assign it to a function. But in using regular functions, you just use your function keyword and followed by the name of the function number generators, let's say number gen, and you implement the function body. But in generator functions, it's not like that. After the function, there's an asterisk in front of this function keyword before the function name. And after this, for demonstration purpose, let's say yield 1, followed by yield 2. So these are the functions we want to return in this, the values we want to return in this function. When the first yield statement is reached, the function will return 1 and the execution will pause. When the second yield statement is reached, the function will return 2 and the execution will pause and later be resumed. So let's try to look at what these values are. When you call this function, we say let's result equal to number gen. Let's log result on the console and see what we've got. We've got an object, which is actually a generator. And this object has two values. Sorry, it has actually two methods, the value and the done. So let's say result.next. When you call the next method, let's log it to the console and see what we have. Value 1 and done first, because the function has not finished its execution, but it paused due to the yield statement it encountered. So after this yield statement, it will continue execution. Now, when you call result.next.value, it will log 1 to the console because that is the value at that moment. We have 1. And if you log result next done, it will log false because the function paused execution, but it has not done with its execution. It's paused because of the yield statements it encountered in the function body. So generator functions are actually different from regular functions. When a yield statement is encountered, it will pause its execution and return an object which contains the value and the done property. Now, with the next method, you can continue execution. When the next method is invoked, the function execution continues to the next yield statement in the function's body. So this is just a simple syntax for a generator function. Now, moving on, let's look at, we've already looked at the syntax in this very simple example. So let's see what's happening under the hood. Let's visualize this process. Let's visualize how this function is executed and how it pauses and resumes execution. Let's use our usual tool here, our Python tutor tool, so we can visualize this code. Okay, it's still loading, and I don't know why. Why it's still loading, let's, okay, it's done loading. Let's quickly copy our function here and then paste it in here so we can visualize what's actually happening. So in this case, let's make some changes. Value, copy this, paste it up. We'll copy this here and paste it 2 more times. Then execute this function. When you execute it, okay, now we have a generator function. So when you click next, what is returning is an object. Click next again. The result here is an object, and the object contains the value and the done properties. Next, and the number function, the number generator starts its execution. In this case, it was being prepared to start execution, because when we call this function and we assign this function to result, except the result is being invoked, the function will not begin execution. So now we're about executing this function. Then we click next. The return value here, we have value 1 and done is false. You have, this is an object with key value and key value, and the value is 1. This one, the key here is done and the value is false. Now we click next. Look at what is happening. After the first yield statement, the function pauses execution and return control back to the global frame, and the value is returned to the global frame, so we can actually make use of the value. Now, when you click next, note that the function is done executing, but it pauses execution. Now, when you click the next button again, you execute this function and it resumes execution. And this time around, the second yield statement will be encountered. And with this, when the second yield statement is encountered, the value there will be 2, and the done here will still be false, because the function is not done executing, and we have our value 2 and the done is still false. Now clicking next, we're moving forward. But this time around, when you log the value to the console, you have the value is undefined and the done is true, because the function is done executing. And this time around, it pauses not execution, but it is completely done executing, and the control, it will pass control back to the global frame, and we can see the values here 1 and 2. So that is how generator functions work compared to regular functions. So when it's regular functions, when you call a regular function, it will finish its execution before passing control back to the global frame. But when it comes to generator functions, it will pause execution when it encounters a yield keyword. So moving forward, let's look at the iterator protocol, the protocol behind. Or let's first of all look at the yield keyword, how the yield keyword works under the hood, how it pauses and resumes generator function execution. So the yield keyword is the heart of the generators in JavaScript. Now, what does this yield keyword really do? It pauses execution. When you encounter a yield statement within a generator function, the function's execution pauses at that point. So the current state of that function's variable and execution flow is preserved. Even when the control is being passed from the local frame to the back to the global frame, the current state of that function and the keyword and everything within that function environment is preserved. So what else does the yield keyword does? It returns, the yield keyword can be followed by an expression. This expression is evaluated, and the resulting value becomes the output of the generator function at that point. So when the yield keyword encounters an expression, the expression is being evaluated, and the value is being assigned to the yield keyword, which is returned to the global frame, and execution is being paused at that moment. Now, the yielded value is returned to the code that called the generator using the next method. Now, the third thing that this yield keyword does is resuming execution. Now, after a yield, the generator function is paused but not finished until the done is true. Once the done is false, the execution is paused but not finished until the done is true. So you can resume execution later using the next method on the generator object returned by the generator function call. Now, when a generator, what happens if a generator function encounters multiple yields in the same function body? So a generator function can actually have multiple yield statements, allowing it to yield several values throughout its execution. Each call to next on the generator object will resume execution from the last pause point. That is where it encounters the yield keyword and return the next yielded value. Like for example, what we've done here, when you call this function for the first time, it encounters the first yield statement here, and the first value is returned, and it automatically pauses execution. When you execute this function again, this time around, the environment and every other thing about the function is preserved, and it continues execution where it's previously paused that very execution. So when you execute this function now, at first it encounters the first yield keyword, there's execution post, and then when you run the function again, it continues from where it stopped. So there's a difference between generator function and regular functions. Okay, so moving forward, the yield keyword in generator functions, it's very important to understand. Once you understand the yield keyword, every other logic will be in the function body, but the yield keyword needs just an expression that will return a value, either a string or another function or a number or anything you wish to return. But the yield keyword must return something, either undefined number. It must be a value, either a null or undefined value. So what actually is the iterator protocol and how does it play a role in generator functions? Now in JavaScript, generators are under the hood. Generators are linked to iterator protocols. So the iterator protocol defines a standard way for object to be iterable. It specifies that an iterable object should have a method named symbol.iterator. And later in this class, we'll see how symbol.iterator can be used to implement custom iterables. Now, the symbol.iterator that returns an iterator object, this iterator object then has a method named next that when called returns an object with two properties. What are the two properties? The first property is the value and the second property is the done. So the value is the next value in the iteration sequence. While the done is a Boolean indicating whether the iteration is complete, true, or false, which means the iteration is not yet complete. So generators and protocols, how do they link? How are they connected? How are they interwoven? Now, while generators themselves don't explicitly implement the iterator protocol, the generator object returned when you call a generator function act as an iterator. This object implicitly follows the protocol. Symbol.iterator calling symbol.iterator on a generator function itself returns the generator function back. When you call a symbol.iterator on a generator function, it returns that function back. Now, this might seem a kind of confusing, but it essentially signifies that generator function itself can act as a starting point for iteration. And as we move on in this class, we get to understand what iterables are, what an iteration is, what iterators are, and how they can be implemented manually. We will implement our own custom iterables so we can get to understand what exactly is happening under the hood for all these loops and every other thing being implemented for us. So the next method, the generator object has a next method. Each call to the next method on the generator object resumes the generator function's execution from the last pause point. And this may seem like too much English, but then if you understand the iterator protocol and the yield function, iterables, and everything happening under the hood, you understand generator functions the more. So when you call the next method, it resumes the generator function's execution from the last pause point. And then it evaluates any expression following the yield statement. And after that, it returns an object with the following properties, as we earlier mentioned, the value property and the done property. The done property is a Boolean. The done property, the key is actually done and the value is always a Boolean, while the value can be any value, a string, a number, or anything assigned to the value. And if there are no more values there are no more values in the generator function, the done property returns true. But if there are more values or more yield statements to be executed, the done property actually returns false, indicating that the generator function is done executing. And that's one beautiful thing about the generator functions. And later in this class, we'll see how we can use generator functions to implement synchronous operations without using promises or async await. Now we now understand what, not fully, but partially we now understand what the iterator protocol is. And as we move on in this class, we fully understand what the iterator protocol is and what it stands for, what work does it, what work it actually does under the hood in generator functions. But right now, let's move over to infinite sequences, how we can use generator functions to implement infinite sequences. Now, you know what an infinite sequence is. When you call, let's say, for example, when you implement a while loop without a breakpoint, that is an infinite sequence. That loop will continue to execute. It will continue to execute till it consume the whole of your computer memory. But then let's see how we can use generator functions to implement infinite sequences. Let's say, for instance, we have a function, the same number generator. And always remember this asterisk in front of the function keyword before the name of the function in generator functions. So we have number gen, not caps, number gen. And what we want here is we're implementing an infinite sequence using a generator function. So in this case, we say let I equal to 1. We'll start iterating from 1. Then we'll say y true. And this will always return true because true is always true. And then we'll say yield I. Then we increment I. That's every time we yield I, we increment I is equal to I plus 1. I plus plus simply means I is equal to I plus 1. That we're incrementing I so that the iteration, I mean, the loop will continue and to not break. So when you call this function, and if you call it manually, anytime you invoke the next method, I will increment and the value of I will be yielded. And now, why using true? Simply, true is 1. Computers only understand zeros and ones. And true is basically 1. And why false is 0. If you don't want to use true here, I can equally say 1. Why 1? Yield. And 1 is true. True is 1. Why false is 0. And 0 is false, as we all know. Now, the natural numbers, the number generator function here is a generator function. It uses a while loop to create an infinite loop. Now, this is an infinite loop. It will continue iterating over these values till it gets to 1,000, 1 million, and I will keep incrementing because we are not actually breaking this. So an infinite loop is actually an infinite sequence. So let's see how we can use this infinite sequence. This is implemented without a breakpoint, but then we can make use of it and introduce breakpoints. Now we can call this function. This const nums is equal to number generator. And then inside of this number generator, we can see, we can use a loop for const n, const num of nums log num. Now, if I execute this code, it will continue logging numbers from 1 to 100 to 1,000 to 1 million non-stop, except I introduce a breakpoint. Now we say if num is greater than 10, then the loop should what? It should break. Now, if we execute this function, sorry, if we execute our code now with these generator functions, now we can be able to achieve what we really want to achieve. Let's say node execute our code. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is how generator functions can be used to implement infinite sequences. Now let's comment this line here and execute this code once more. As you can see, we're at 3,000, 40,000, 50,000, 60,000, and the number keeps going. So let's stop the code. We're at 13,000, is it 132,364 in just a couple of seconds because we did not introduce any breakpoints. So this is an infinite sequence, and if you don't have control over it, you actually in trouble. So there's a way we can go over this manually without doing this using a for loop. So let's see how this for loop it's working. Let's see how it's working under the hood. By going this going over this the manual way, we can see let result equal to, or let's change this one to result. Let's see, let result equal to number generator. And we see, let's see, this is the number equal to number generator, and we see let result equal to number next. We're calling the next method directly. And when we use a while loop to implement this, we say why, we check if the DOM property is false. Why it is not false, we want to continue yielding these values. We want to continue printing these values to the console. So why result, the DOM property, this is false. This will evaluate to false, because we're saying why this is still false. Why this is not, why it's not false, we want to log the value to the console, and we'll say result value, like this. And then we want to check, we reassign result to numbers, that is num results. We reassign results to another value, which is the next. We call the next method that returns the DOM property and the value property. Now this time around, let's execute our code and see what we've got. Oh, we got an error here. Next is not defined. Okay, result is equal to number next. We call the next method on the number property. Sorry about that, typo error. Now when we execute this code, this is actually an infinite loop. Can you see how this it's an infinite sequence? Why result is not done? This should, we want to go to the next value, and then we want to log the value on the console. Now this is very, very simple. When you call the next method, it returns a value property and the DOM property. Now what here we're checking, we're saying if done is false, we want to log the value to the console, and we want to move over to the next iteration. And in this case, this is an infinite sequence because done will always be false. You know why? Because we don't have any definite values here. Done will always be false because the generator function will keep on executing because this value, we're starting from 1 and then going to 1,000, 2,000, 3,000, 1 million. So that is how we continue executing this loop. We continue executing and then printing values to the screen. And here we have 81,269. So it will continue till it gets to 1 million, 2 billion, 6 billion, and so on. So this is how generator functions can be used to implement infinite sequences, like infinite loops. You can use the for loop or the while loop, or anyhow you wish to go about this, but you should make sure you have control over this, because by the time you forget to implement measures that will stop the loop, that's where you run into problems and your application will never work as intended. Because by the time you iterate over 1 million numbers, 2 million, and you keep iterating, it's consuming memory. And by the time you know, you run out of memory and you don't even know what's happening. You have to debug your code and keep on debugging until you get to understand what's happening. So moving on, we have asynchronous generators. So while generators themselves are not asynchronous, they can be combined with the asynchronous nature of JavaScript to make to implement asynchronicity and make your functions synchronous and even your loops. So traditional generators, after the function keyword, we append it with asterisk, and it allows you to pause and resume execution. They are synchronous, they are not asynchronous. But in asynchronous programming, it deals with handling code that takes time to complete, like fetching data from APIs and all of that stuff. So how will this work? You combine an async function with a generator function. So you define a function using an async keyword, and then you add an asterisk in front of that function, making it a generator function. And this time around, this function will pause and resume with promises. Can you see how powerful that is? It will pause and resume with promises, and it will also yield values. So let's take a look at a brief example to see how we can combine an asynchronous nature of JavaScript with generators to actually implement a synchronicity and fetch data from APIs or all of that stuff. So let's assume we want to fetch users from this JSON placeholder API. We want to use this JSON placeholder API and want to fetch users. Always remember that after the function keyword, there must be an asterisk in front of the function keyword before the name of the function. So we have function fetch users. And since this is not a promise, we must handle errors like this, try catch. In the catch block, this is where we log errors. We say, or we'll say something like console.error. Error. We simply log the error to the console. Error. Oops, error like this. And in this try block, this is where we implement our data fetching logic. Then we say log, let's say fetching users, so that we know that, okay, actually the function is now fetching user and we have to wait. We say const response is equal to await fetch and the JSON placeholder URL https://JSON placeholder dot type code like this .com/users. So after we're done fetching the users, now we want to convert the response to, let's invoke the JSON method const users is equal to await. It's an async function, so we await response.json. And when we're done, what we'll have to do is we'll iterate over the users and we yield the name, because this is a generator function combined with an async function. So we see for const user of users yield user.name, because we are very sure that the name property is on the user object. So that's why we are directly saying yield user.name, or if at all we are not sure, we say if user.name, then yield user.name, but we are actually sure that the name property is on the user object. So now it's time to use our function. So in this generator function, we're actually fetching users from the JSON placeholder API, then yielding the user's name. Now let's use this function in our code. We call the main from async function main. This time around, this one is not a generator function, it's a regular function, because we're trying to invoke our generator function. We also handle errors here, try catch, and inside you can say console.error. any error we come across. Now, in our try block, we will simply say const user iterator is equal to, we'll call our fetch users function. And as you call this function, you can see it's an async generator function. And it's returning any void or none and all of that. Okay, so now let's see how we can use our async generator function and then log the users names. You see, for async const user of user iterator log user, let's say const username of, we want to log the username, not just the user. Const user of user iterator log the user's name. Okay, it's await. Okay, this is await, not async, and that's the reason why we're getting an error here. We have an async function and calling await. So this time around, we've used this generator function to actually fetch users, and we yield the username. And it's time to use this function here to print the user's name on the console. So now, after iterating over all the users, we print the username. So let's execute this code and see what we've got. Okay. So the reason why we're getting nothing on the console is because the main function is not called. Let's call the main function here. And this main function is returning the promise. And the promise is returning void. It's returning nothing because we're returning nothing in this function. We're actually executing the function and logging the usernames on the console. Let's do this once more, fetching users. Okay, so now we have all our users on our console. And notice what happens when I execute the code, you see fetching users to tell us that, okay, now we're getting the users from the API. And after getting the users, we log them on the console. So that's great. That's how we can combine regular functions with, we can combine generator functions with asynchronous JavaScript nature to actually implement powerful code. And this is awesome. If you don't want to use promises or you don't want to use async await, you can actually combine these generator functions with the asynchronous nature of JavaScript to perform other asynchronous operations in your code. But it's always advisable to use promises and async await, since the syntax is very straightforward and you don't have to go about implementing all of this logic that's happening here. Okay. So moving forward, we're actually done with generators. We now know how generator functions work, what the keyword does, how they are implemented using the iterator protocol under the hood, how we can use them to implement infinite sequences, and how we can use asynchronous generators to actually manipulate data, fetch data from APIs, and do other synchronous activities. So now let's move on to iterators. So what are iterators? Under iterators, we'll be looking at the iterable protocol, the iterator protocol, the built-in iterables, the custom iterables, and we'll also see how to iterate over objects. So what are iterators? Iterators are objects that let you have access to elements of collections one at a time. They let you have access to elements of a collection one at a time in a sequential order. And that is why they are used to implement loops under the hood, because they let you have access to elements of a collection one at a time in a sequential order. They provide standardized way to move through the elements of a collection, like an array, list, or some custom data structure. So what iterators mainly do, what they really do is they act as a bridge between collections and algorithms. Like they allow algorithms to work on various collections without needing to know the specific implementation details of each collection. Now, an iterator typically has a next method. Calling next moves the iterator to the next element in the collection and returns the value of that element, as we've been doing. Anytime we want to move to the next objects in that in the generator function, we call the next method, which will provide the value at that step, the value property, and the done property, which is a Boolean. Now, some iterators also have additional method like has next or reset. But these methods depend on the specific implementation of those iterators. So what actually are the benefits of iterators? Now, iterators promote code reusability. Algorithms can be written to work with any iterable collections, a collection that can be provided in an iterator without modification. So they improve code clarity by separating the logic of iterating over a collection from the logic of processing the elements. So that's why you iterate over an array of lists or any iterable object without knowing the implementation details. That's where iterators come in. Now, for example, let's look at the iterator syntax, just using an array, a simple array. Let's say we have an array of numbers. 1, 2, 3, 4. We have an array of 4 numbers. Now, when we call this array, this is const iterator is equal to numbers, and then we pass in the symbol dot iterator. Now, this symbol dot iterator will get you confused at the moment, but later in our code or later in this class, we get to understand what symbols are and what the iterator object is on symbols. So now when we call these numbers and we pass in the symbol dot iterator, remember symbols are unique and they always return unique elements in iterables. Like in this array is an iterable. So this symbol here will always return a unique element at a particular point in this array. Now, when you call this, when you call the next method, let's say iterator dot next. Let's say we want to log it to the console. Oops, we want to log it to the console like so. Now, when you log this to the console, we have the property of value, which is 1, and the done is false. Can you see how this symbol that iterator is returning unique values in this array? Now, let's log this to the console once more, or let's say 3 times, or even 4, and log this to the console. We have value. The first one, we have an object with a value property and the value 1, and the done property with a Boolean value of false. So now we have another value. The second object has a value of 2 and the Boolean value of false. The fourth object, which is the last, which represents the last number in the array, also has a value of 4, and the done property is also false because we've encountered the last value, but we've not checked if there's another value in the array. Now let's add another console here to check if there's another value in the array. Now this time around, there's no value, and the value here is undefined, while the done property is true. And when the iterator encounters a value of undefined, the done property becomes true because it is done executing and finding values in that iterable. So once there are no values, the done property is true. So I'm done here. My work here is done. So done is true. Then value is undefined because there are no more values to process. Now this is an iterator, but there are several things happening under the hood in arrays and the loops we use in processing array and iterables like arrays. There are several things happening under the hood. But in this class, we'll try to understand what exactly is happening under the hood and how all these are implemented. Now, we have an iterable here. In this example, we have an iterator for the numbers array using symbol.iterators. So when you call next on this iterator, the iterator moves to the next element and returns its value. Not only its value, but it returns an object for that element, which contains the element itself, the value contains the element itself, and another property, which is a Boolean indicating if it is done accessing all the elements in that iterator or in that iterable, which is the array. Now, the difference between iterators and iterables. I've been mentioning iterables, and iterators, and you may become confused. Now, iterators, the actual objects that allow you to iterate through a collection, providing the next method and potentially other methods that you can also use on that on an iterable. Let's see. Now, iterators, the numbers here, it's not an iterator. The iterator is this object here that provides an iterator method that we can use to access the next method on these iterable numbers here. Now, what is the iterable here is the array, while the iterator is the method we're using to process the array. Once more, the iterable is the array we are processing, while the iterator is the method, the object we're using to process that array. Now, iterables, which are collections like arrays, strings, maps, sets, that can provide an iterator when you try to like access and process them. So you need to know the difference between iterators and iterables. Iterables are the elements which we are processing, while iterators are the objects and methods we are applying to process those elements. So we've looked at the iterator protocol. Now let's move over. We've looked at the iterable protocol. Now let's look at the iterable protocol. The basics of the iterators. We've learned what iterators are, how we can use iterators to process iterables. Now let's look at the iterable protocol followed by the iterator protocol, because they all have protocols. The iterator protocol ensures that an object must return at least the value property and the DOM property. But let's first of all look at the iterable protocol. So the iterable protocol in JavaScript defines a standard way for objects to be iterable. This means they can be used in loops, like a for-up loop, a for-in loop, or all of these JavaScript loops you can mention. So the components of an iterable. The iterable has a symbol.iterator. This symbol is a property on it's a built-in symbol object that acts as a marker for the default iterator method of an iterable object. Always recall that a symbol is unique, even if you don't know. The next thing we're going to be discussing is symbols, and we can see how unique symbols are. So symbol.iterator, this symbol provides the iterator method that operates on these iterables to actually access its unique elements. Now, the iterator object, when you use an iterable object in an iterator context, JavaScript calls the object symbol.iterator method behind the scenes. This method is expected to return an iterator object. So what is the iterator object? The object that contains at least two properties. The first property is the value, and the second property is the done, which is actually a Boolean. Now, the iterator protocol itself, this protocol specifies the behavior of an iterator object. It requires that the iterator to have a method named next. And this next, when invoked, provides the next value in the iterable. And it does not only provide the next value, but it provides an object that has a value property and the done property. Always recall that the done property is a Boolean. And when it is false, it means there are still elements in the iterables that can be processed. But if it is true, that means the iterator has no work to do with the iterable and every element has been processed. Now, the next method is the core property of this iterator protocol, iterable protocol, because calling the next method on the iterator object advances the iterations and return an object with two properties, the value and the done. So like when you call an iterable object, let's say you want to iterate over an array using a for of loop, JavaScript internally calls the symbol.iterator method that retrieves the retrieved iterator object implements the next method. So when it calls the symbol.iterator, immediately the first item is returned. It invokes the next method, which returns the second element. And that second element there, it returns an object that actually contains the element. So the object has two properties. Always remember that it has the value property and the done property. Now, the for up loop keeps calling the iterator next method until the done property returns true. Like loops, especially the for of loop that we're talking about, it keeps calling the next method till the done property is false. And we're going to be seeing how we can do this automatically with the for of loop and how we can implement it manually. Now, let's assume we have our array of numbers here. We have an array of numbers. And this array of numbers, we can simply see for const number of numbers. We want to log each number to the console, log number, and then we clear our terminal. Then we run our numbers. It's nums, not numbers. Okay, so what this loop is doing under the hood is when we call this, when we execute our code, now it is checking when it's bringing out the element one by one. But what is returning is an object with a value. So what we are logging on the console here, it's actually returning the value so we can have access to it. But then it's taking care of the done property under the hood, checking if the done is true. Immediately the done is true, the loop will stop iterating over the number array. So it's using this protocol under the hood to give us access to these numbers, but it doesn't give us access to the done property. It only gives us access to the value because that is actually what we need. We don't need to know the implementation details. We only need what we want. So our lives becomes easier. Now it's the same as calling number symbol.iterator in this array and then accessing the next method. But since we're not doing that manually, this is actually is being taken care of under the hood for us. Now, let's see how we can create a custom iterable using an object, using a class. Let's assume we have a class name, let's say number range. Number range here. And this class takes a constructor of start and end. Start and end. And now we have this start is equal to start. This dot end is equal to end. And the this keyword as used in this class is not referring to this very class. It's referring to the object that is created when this class is invoked. Now, it is referring to the object that is created when this class is being called, and this class can be called, this object can be called using a new keyword. So that object that is created when you invoke this class using that new keyword is this context being referred to. Let's say, for instance, you have const new obj equal to new number range, and you pass in 1 and 5. Now you have a new obj named new obj. So this keyword here is referring to this new obj. So when you say this dot start is equal to start and this dot end is equal to, so the start here is 1. It is not referring to this very class, the constructor here, but it is referring to this new object you've just invoked with the new keyword. So let's see how we can implement the custom iterable. So now we have this method. Initially, when we were discussing the iterable protocol, we discussed about a method, the symbol.iterator, that actually returns an object with a value property and a done property. So, we have in objects, we have methods and properties. So in this case, methods are also functions that perform some kind of operations. So let's assume here we have this method, symbol iterator. So this is the method that we use to iterate over the numbers being passed in this number range. So what let's current equal to this dot start. Now, what do we want this function to return? Always remember that this method always returns a next method, and this next method contains two properties, the value property and the done property. So we want to return a next method in this very method here, this symbol iterator method. We want to return another method, which is next. Next is a method. And what do we want to do in this next? Now we want to check if current is less than or equal to this dot end. What do? We want to simply return value, which is the current value, and done, which is false. At this point, we want to check if the current value is the starting value. So we're incrementing the current value, but we also want to check now if the current value is less than the value at the end. And for instance, we have 1 and 5. So we want to, we're incrementing this, let's say current plus plus, because in every value we increment the value. So we keep on incrementing, but we're also checking that if the current value is less than the value, the biggest value we supplied, if the current value is less than that value, we want to keep incrementing till we get to our end. The end is here is 5. So if 1 is less than 5, we keep incrementing. 2 is less than 5, we increment again. 3 is less than 5, we increment. 4 is less than 5, we increment. And when we get to 5, we will stop, because 5 is the biggest value and we don't want to surpass 5. So we say else. This time around, we will return done true. So this is a custom iterable. And now for this object we used as a sample earlier, let's try to use this objects and see what we've got. Now we will see for const number of, let's say numbers here. Numbers. They will say const number of numbers. We just want to log the number to the console. Log number. And let's try if it works out, or we have a kablooey. Okay, so we're not actually having any value on the console. Okay, let's log numbers. Let's see what we've got here. We have start 1 and end 5. Okay, so constructor here, symbol iterator, we have current go to this dots. Okay. This is actually a number with number properties, but then why are we not getting anything on the console? Okay. Okay, let's try a little of debugging. Let's log nums. Nums. Okay. I think there's a kind of an error here, but I can't seem to figure it out. That's why I love TypeScript. TypeScript will just point it out to you. 5 numbers start 1 and 5. Okay, so what is going on? What is going on? Let's try to find this. And okay, so since I can't find what's going on, this is our iterator protocol. It's a method that returns the next object, and this, sorry, the next method, and this next method contains the value, and here we say value is undefined, and done is true. You can just note that. Numbers log none. Okay, let me see log. Okay, it seems we're not even getting access to this loop. But that's by the way, we'll get to that. We'll get back to that. Let's proceed first. Yes, that's true. But this is a kind of a different. We can't call this because this is numbers, and you can't say numbers. Can you see? You can only access the constructor, the end, and the start. And this is a different case altogether, but we'll get back to that in a bit. Okay, so now with our custom iterable not working as expected, let's move over to the iterator protocol. Okay, so what exactly is the iterator protocol? And I will look into that issue before the end of this class, or maybe after the end of this, after this class, and I will try to get back to you what actually is wrong with the object and the mistake I've made. Since I can't figure it out, I'm just looking at it. The iterator protocol is a standard way for objects to be iterable, meaning they can be used in for loops and other contexts that expect a sequence of values. So it defines a contract between iterable objects and iterators, ensuring consistent behavior across different data structures. So the key components of the iterator protocol are the symbol.iterator, the iterator object, and the iterator protocol itself. As you all know what the symbol iterator is, what the iterator object is, and what the next method is. This is the core function of the iterator. When calling the next method, it returns a value, the object with the value and the done property. So when you call an iterator object, it internally calls the symbol.iterator method to retrieve the iterator object, which implements the next method and returns it as defined by the protocol. So like the for-up loops and other loops iterate by repeatedly calling the iterator's next method. So it keeps looping until the done property returned by the next becomes true, that it signals the end of the iteration. Okay. So moving on, the iterator protocol and the iterator protocol are not, there's not too much difference. Moving on, we'll look at the built-in iterables, custom iterables, and iterating over objects. So moving on, in building the built-in iterables, from there, when we proceed to the custom iterables, we'll be able to maybe figure out what actually is wrong with our custom iterable object. And the built-in iterables in JavaScript are objects that you can directly use in for loops and other iterable contexts like array prototype for each, array prototype map, and array prototype other higher order functions in used on the array prototype to manipulate arrays and all of that. So in arrays, you can simply use a for of loop to iterate over a string, an array of numbers, or an array of strings. Something like if you have a string, let's say you have const languages is equal to JS, Python, and let's say Java, and you want to iterate over this array, you say for const lang, let's say lang of langs log, want to log the language to the console. Okay. And then if you execute our code, you see that we have JS, Python, and Java. So if this is also a string, let's say we have a string here of no longer have an array, we have JS, Python, Java. Let's execute this once more and see. We have, okay, so we're iterating over every single character because this is an array of string, and we can iterate over it and print every single character. And not only that, we can also iterate over sets. Let's assume we have const length is equal to new set, but in here we have JS, Python, C, and JS once more. Sets are collections of unique values. So when we try to iterate over this, we see for const lang of length Let's language of languages. We want to log each language to the console. Let me say lang. Now we print this to the console. Oops. Now we print this to the console. Then we have JavaScript, Python, and C. But then we don't have JavaScript at the end. We have JS, Python, CJS, but in printing it out, we don't have JS because sets a collection of unique values. So if you add a value twice, it will only be printed once. So this is how we can iterate over a set. And we can also do this with a map. We can say this is equal to new map. We can iterate over map. These are built-in iterables. So we can say here, a map is actually a collection of key value pairs. You can iterate over the key value pairs in insertion order. So we have an array, and we have another array here. Then we have name, KodeCamp. This is a comma, not a colon. KodeCamp, and another array of age 4. Now when we iterate over this, we have name, KodeCamp, age 4. Okay, so we have two properties here. We can actually destructure this and we can have something like this, because what we are printing is an array, and instead of, we want to destructure this array, and we have the key value. Then we can log something like, we can do something like this, key, and then value, like so. And this log this once we see that name, KodeCamp, age 4 in a string format, no longer in an array. Now we can actually use string literals also. Instead of doing something like, we can say const character of this string of KodeCamp, and then log each character on the console. And this will work perfectly well. KodeCamp, string literals, because in declaring a variable and assigning a string literal to it is the same thing as just hard coding the string literal itself in the loop and then processing over it. Okay, so this is how these are the built-in iterables. You don't have to implement this all by yourself. They're already built in. And moving on, we have custom iterables. So in JavaScript, custom iterables allow you to create your own data structures that can be used in for-up loops and other iterable contexts like arrays, just like built-in iterables like arrays, strings, and the rest. So this enables you to extend the concept of iteration to handle more specialized data or custom logic. And this is, always remember that the symbol iterator is very important in all of this, and the next method. So the symbol iterator returns the next method, and the next method in turn returns an object, which contains the value and the value property and the done property. So when implemented, it returns the value property and the done property, which you can then use to track if you are done iterating over an iterable or not. So you can determine when to stop and when to continue. So the benefit of custom iterables here is flexibility. You can tailor the iteration behavior to your specific data structure or logic, and code reusability. The use case is representing custom data structures like linked lists or trees that don't directly map to built-in iterables. and then implementing lazy loading or on-demand generators or elements during iteration. But then when implementing custom iterables and custom iterables, you have to be very, very careful not to make mistakes. You have to have total control so as to know when to stop and when to continue. So custom iterables are simple to implement, but then I can't really figure out what happened to us. But then I will do just in just a minute. Let's move on to iterating over objects. So iterating over object in JavaScript is a bit different in iterating over other iterables like arrays, maps, and sets. In iterating over objects, you use the in keyword. You use the in keyword instead of of. So you, for instance, you have an object. Const object is equal to name. It's a code camp and age here. Let's say 4. And you want to iterate over this, you can simply say for const key in obj, that is object. You want to log key to the console like this. Let's clear our terminal and run this once more. And we have name and age. We're only logging the key to the console, not the value. And then we can see if you want to log also the value, we can do something like key, and we can specify the value, which is obj, and then we can access the key in that object like this. We have name, KodeCamp, age 4. Now, in doing this, we're actually accessing the value using the key. So the key to access the value KodeCamp is name. And when we get to name, we actually access KodeCamp, which is the value using the key here. And then we log it to the console. And we have object keys and object values. We can say const keys is equal to object keys. And then we pass in the object we are talking about, which is the obj. And what we do here is this is now an array. Now let's change this to off. Then we say keys. But first of all, we'll log also keys to the console. So we'll see what we've got. Now let's log this to the console. Now we have an array of name and age. So we are converting these object keys to an array by simply using the object keys method to convert the keys in this object to an array. So we can use a for of loop to iterate over it. And then we can say const key of keys log key. And we can actually log the key to the console. We have name, age, which are the keys. And let's remove this. We can log name and age, which are the keys. And then object values. We also have object values method. We have value, or let's say key of keys, because let's change this to values. And in here we have const value of values. Then we log value to the console. And we have KodeCamp and 4. We have the first value is KodeCamp, the second value is 4. So that's how to access the object values. And if you log this, if you log values to the console, you discover it's an array. It's values we have KodeCamp, and we have for as values. Nice. Object entries. And what's the object keys? If you only need to iterate over the object on enumerable property names, that is not including inherited ones, you can use object keys. It returns an array of the object on property keys, and the object values. The object keys, object values, and object entries were all introduced in ES8. So if you only need to iterate over the object on enumerable properties values, you can use object values. And then it returns an array of the object on enumerable property values. Then object entries. If you need to iterate over both keys and values together, you can use object entries. Okay, now we can do something like we have entries, and then we have object entries. Then we pass in the object we want to actually iterate over its entries. And let's log entries here first. And let's comment this for loop. Run our code, and we have two sub arrays in this array. We have name, KodeCamp, and age 4, because we're iterating over both of the keys and the values. So now let's access the keys and the values here. Now, if we iterate over the first array, let's assume we're iterating over the first array here. We have entries, because value of entries, we want to iterate over the first array, that is the outer array. Now we want to log the value to the console. Now let's log this value to the console and see what you've got. Okay, now we have, okay, let's do away with this so as to be clear. Now we have name, KodeCamp, age 4. Now we have to destructure this. Well, let's get the key and value as well. Now let's log key plus value. Log this to the console. Okay, now we have key here and the value. We have name plus KodeCamp, or we can do something like this. A colon, not a plus. We have name, KodeCamp, and age 4. Okay. Okay, Toby. We'll go back to that. Let's finish with this first. Okay, so now we are destructuring the key and the value from the entries and array, and then logging it to the console. So this method is used if you want to access both the value and the key of the object. So choosing the right method. So using for in if you need to iterate over all properties, including inherited ones, and access them using the key. So using object keys, if you only need to if you only need the object on enumerable property names. Now you can use the object values if you only need the object on enumerable property values. You can use object entries if you need to iterate over both keys and values together. Keys, if you're iterating over only the keys, the values is for getting only the values, iterating over only the values, while entries is iterating over both the values and the keys. Okay, so now we've learned how to iterate over objects. Not only we've learned about the built-in iterables, the custom iterables, and we've also learned how to iterate over objects. And next on our list, we have symbols. Okay, so we've been using symbol iterator, but we don't really know what symbols are and what the iterator method is. So symbols are actually primitive data type introduced in ES6. That is ECMAScript 2015. They represent unique and immutable identifiers that are guaranteed not to conflict with any other variable or property name in your code. So the key characteristics of symbols are each call to a symbol creates a new and unique symbol value. If you call symbol with the same description string, it will still return distinct symbols. Now, immutability, the value of a symbol cannot be changed once created. And the reason why we use symbols is because symbols are particularly useful as property keys for objects. Since they are unique, they can be used to create private or non-enumerable properties that won't clash with other property names, like including those properties that are inherited from the prototype chain. So this helps prevent accidental property name conflict. And also the global namespace protection. Symbols can help avoid naming collisions in a global namespace. Since they are unique, you can use them for global constants or identifiers without worrying about conflict with variable or property names. And you can also use symbols in weak map and weak set for as collections. These collections allow garbage collection as the key object when other references to them exist. Like weak sets and weak maps, they allow for garbage collections. If there's no reference, if there's nothing referencing them, they are garbage collected. We already know what garbage collection is. And creating symbols. Symbols are easy to create. You can see const symbol is equal. Let's say symbol one is equal to symbol like this. And the description is optional. Or you can see symbol two is equal to symbol with a kind of a symbol two description. This is the symbol description. And when you check to see if symbol one is equal to symbol two, let's see log symbol one is exactly equal to symbol two. Get a false, this will return false because symbol one is not equal to symbol two. So using symbols as object properties, you can see const person is equal to an empty object. And in this object, you try to add a value like secret prop symbol. You say person symbol is equal to some, let's say, some value like this. And okay, we left out the symbol. Let's symbol equal to symbol person. That is just a description. And you can leave out the description and let's say you can say pairs or any description at all. But let's say person. Person is more understandable. And then if you try to log person dot sim, it returns, okay, let's clear our terminal and log this. It returns undefined. So using symbols as property keys, you cannot use access this using the dot notation. You can actually access it using console.log person sim. As you can see, when you try accessing it using the dot property, it's undefined. But when you use the bracket notation here, you get the value. So symbol registry, why not strictly necessary for uniqueness? The symbol for function allows for a global symbol registry. You can use a string to check if a symbol already exists in the registry, and if not, you can create one. Okay, so if you want to create identity symbols, what you can necessarily do here is You can create the first symbol. First symbol is equal to symbol dot for text. And now you can see const symbol 2 is equal to symbol dot for text as well. And now the first symbol, now the JavaScript engine will try to like look at the registry. If this symbol does not exist, then it will create this one. But this second one, it will check and it will discover that the test symbol is already there, and then it will assign this to the test symbol, and these two symbols becomes equal. You say log sim1 is exactly equal to sim2. This returns true. We have true because the symbol is for the symbol that for a method. This actually is a kind of, it provides access to creating weak symbols that you can actually reference, and they are always the same. So let's move over to the well-known symbols. Some well-known symbols, we have the symbol iterator that we've been using, symbol to string tag, and symbol that has instance. And there are some also well-known symbols, like they are not officially part of the JavaScript standard, the ECMAScript standard. We have the symbol.species, symbol.match, symbol.search, symbol.replace, and then symbol.async iterator. It's like the symbol.iterator, but this one is an asynchronous iterator symbol. So the symbol iterator, this symbol is used to identify the default iterator method of an iterable object, the one we've been using and using and using. So we've learned how to use the symbol iterator, and then we've also learned the symbol for. But then let's move over to the symbol for and see how, look more in depth into the symbol for method, and see how we can grab some things about the symbol for. So the symbol for function is a JavaScript. In JavaScript provides a mechanism for global symbol registry. It allows you to, first of all, check for existing symbols. So you can use symbol for with a string key, to see if a symbol with that key already exists in the registry. If it does, then the existing symbol is returned. So if a symbol with a given key doesn't exist in the registry, then the symbol for function will create a new symbol with that key and add it to the registry before returning it. So we try to create a symbol with a symbol for function. To first of all check the registry. Okay, is there this symbol? Does it exist in the registry? Okay, let's just return it. But if it doesn't, then it will create that symbol in the registry, then return it, so that the next reference to that symbol will be returned without being created, as we earlier saw. So the symbol for is optional for creating unique symbols. You can use symbol directly for guaranteed uniqueness. So the main benefit of symbol for is the ability to share symbols across different parts of your code, or even different libraries, if they both agree to use the same symbol registry. So it's generally, it's recommended to avoid creating your own global symbols using symbols with descriptive strings, because it can lead to conflict with other libraries that may use the same string or something like that. Symbol that for it's not commonly used, but then creating unique properties, unique property queues. Symbol that for can be helpful in some scenarios, like shared symbol across libraries and singleting. So in some cases, you might want to create a singleting object. Only one instance exists. So you can use symbol dot for to create a unique symbol as a property key to store the singleting instance and ensure that only one instance is ever created. That is for that object. You cannot create more than one instance of that object. That's where symbols can come hand in hand to create a singleting. A singleting here means only one instance of that object can be created. So if you want to keep track, if you actually want to keep track, You know, a namespace is a collection of different items under an organized environment. So you can say a registry is a kind of a namespace that stores symbols, but symbol itself has nothing to do with namespaces. A registry is a kind of a namespace that stores symbols being created. Let's say it that way. But saying symbol has to do with namespaces, no, that's nothing to do with that. So that's how useful symbol for how the symbol for action is. But you can't just use it like that. You have to consider the negative sides of using symbol.for before using it. Before coming to an agreement and using it in your code, if you're working with a team, you have to discuss, or is it all right? Should I use it? Okay, they say yes, then you can go ahead and then use it. But if not, then you don't have to do that. So moving on, um, we move over to symbol iterator, the one we've been using to actually iterate, to implement iterables and the iterable protocol. So symbol iterator is a well-known symbol in JavaScript that plays a crucial role in defining and utilizing iterables. Symbol iterator is a static property on the built-in symbol object. It represents a unique symbol value. The reason why it's a static property is because when you want to, when you have an object, let's say we have a class, and let's emulate the symbol. We have a symbol class, and we want an instance of this class. What we do is we see new symbol is equal to new, and then we call our like this. And if there's any constructor arguments, we'll pass them in here. But since that is a static method, you implement a static method by calling static before the name of the method. But that we cover that in year 6 because actually classes were introduced in year 6. So we'll cover that in year 6. And here, symbol iterator is actually a static method. And if you have a static method that has an iterator like this, let's say we have this static method and we want to actually make use of it. We don't have to do something like new. All we have to do is symbol dot iterator, and then we can get access to our iterator. If it's a method and we need to call it and pass arguments, we can go ahead and call it, but it's returning void and there's no argument pass. You can leave it because this is the reason why it is static. So symbol iterator is a static property on the built-in symbol object. It represents a unique symbol value. So this symbol acts as a marker for the default iterator method of an iterable object. Iterables and iterators. Now, iterables, these are objects that can be used in for-up loops, you know, like or other iterable contexts like array prototype for each and map and other array properties. They provide a way to access elements of a collection one at a time. So iterators, these are objects that implement the iterator protocol, as we earlier said, and connection between symbol iterator and iterables. When you use an iterable object, you are actually in a for JavaScript internally calls the objects. So you're actually going over this and then trying to access the number manually. And as we demonstrated, without using the for up loops, we had an array of numbers, 1, 2, 3, and then we used a for up loop. Use a for up loop to iterate over these numbers, and then we logged numbers on the console. And in this same, we used an iterator. So const it is equal to numbers, then symbol, iterator, and then we call this method like so. And what is this iterable iterator returning? It's returning a number. As you can see, it is being specified, even though we're not using TypeScript. Then we can say log it dot, dot it next, and then it's returning a number, and then this will return an object, and the object will return a number and any other non-properties. That is, the value will contain a number and a done, which is false. And then if you log this to the console, we have value 1. And if you want this to behave like this, we can actually take this and use it in a for loop, and it will behave exactly as using this directly in a for loop. So the key points behind this all is you don't need to explicitly define symbol iterator on your iterable objects. Built-in iterables like arrays already have a default implementation. However, if you are creating your own custom iterable data structures, you will need to provide a method named symbol iterator that returns an iterator object following the protocol. So that's how symbol iterator is used. We've been using it since we started this class, and you should get accustomed to it. And the next on the list is symbol specials. So symbol special is a well-known symbol in JavaScript that's primarily used by built-in constructors like arrays or strings. So under certain circumstances, you can't just use symbol specials. You will have to use it, and this is mostly used by library builders and all of that. But let's just take a look at it and see how we can actually use it. Now, let's say an array is a class. Before we go into this, let me make this clear to you. An array is a class. Being a class is an object. A class is just a syntactical sugar to name our object. So an array is an object by which every it has a prototype that all its methods can inherit from. So let's assume we have an array. That's why you see array, which is a class, log type of array. Okay, let's see what we get here. It's a function. Okay, being a function, functions are first class objects. This is actually a function, but it's a constructor. Being a function, I don't expect it to return an object. I expect to return a function, because constructor functions, you know about constructor functions that are like array. You have something like this. Then you pass in the properties here. They say name, age, and all of that. And in here you see this dot name is equal to name. So this is a constructor function. This is actually a constructor function. So this is how classes were implemented before ES6 introduced the class keyword. So if you log this and it returns a function, it means it is a constructor function. If you hover over this, you see array constructor. Okay, so now if you want to extend this, you see using the class key, you say class my array extends array, like so. And now you say const norms is equal to new my array, and then you pass in 1, 2, 3. Let's say 1, 2, 3, and you want to access the length of this. Okay, you don't even want to access it. You want to check the instance. You see log, let's say nums is instance. Okay, no, instance of array. Now, if you log this to the console, it returns true, because you are directly inheriting, extending the array object. While extending it, then you are creating a new object, the class you extended from the array. And if you check if the number is an instance of array, it will return true because you are extending this from the array. So that is where the species, the symbol species comes in. So symbol species is a constructor that provide a way to override this default behavior. Now, if you want to use symbol species, you can say static. Instead of this, inside of this array class that you are extending, you can say static. This is a static method. Get symbol species, like so. And then you return array. Behind the scene, what you are inheriting, you are extending this from the array and you are inheriting the array. This array is inheriting from this array object, but you don't want this instance to be direct instance on array. Now, if you log this to the console, okay, this will return true. Log nums instance of my array. True. Both are returning true. Here, when we modify my array, we define a static getter property. This getter returns the array constructor. Now, when you create a new my array instance, symbol species hints use the array constructor for object creation. So this results in an object that's only my array and not my array. So what's actually happening here is we're trying to extend this array, this my array from the array. This is inheritance. We are inheriting this array object and we're extending it in classes. We don't extend, we don't call it inheritance, we call it extending. We're extending this and then we're adding a property that returns the array object, which is a constructor function. But in classes, we can actually inherit it like this. And then when you call nums is equal to my new array, and then you log the instance, it returns true. And here, oops, okay, here is supposed to return false. Symbol species. Static get symbol species return array. New array, my array 1, 2, 3. Okay. Nums instance of this. And this is supposed to return false and okay, so we've encountered another error here. This is supposed to return false and this is true because we've now used symbol species here to we're inheriting from the array constructor function, which is an object, but then we don't want this instance to be of an array, but to be of my array. And now let's remove this, run it once more through, and okay. Okay, so it's a bit of an error here, symbol species, and okay. So let's just move forward and I will fix that later. I think there's a kind of an error here that I can't possibly figure out. I'm trying to figure it out, but I can't possibly figure out. And we'll figure that out soon. but not now. Let's just move on. Okay, but then what the point here is, this is supposed to return here false, and this is supposed to return true, because nums now is an instance of my array, but not instance of array, because this is handled under the hood, but not explicitly. Let's move on and then we figure this out next. So we define a static getter property named symbol species. So this getter returns the array constructor. Now, when you create a new myArray instance of symbol species, it hints to use the array constructor for object creation. So this results in an object that only my array and not an array. But then I don't know why it's returning true. Maybe because of something I don't know. The reason I don't know why. The symbol species can be helpful in specific scenarios where you want to control how derived objects are created from built-in constructors. For example, you might use it to ensure that subclasses always return instances of their own class when methods like slice or map are called on them, which often return new arrays by default. So using symbol species can add complexity to your code. That is the important considerations of using symbol species. They can add complexity to your code. It's generally not necessary for most everyday use cases. But if you feel you want to use it, you can go ahead and use it. And I guess we've come to the end of this class. And in this class, we actually looked at generators, iterators, and symbols. So we discussed what generators are, what you can use generators for, how to combine it with the JavaScript asynchronous nature to perform asynchronous operations. We looked at iterators, iterator protocol, and iterable protocol. And we also looked at symbols and some well-known symbols and how we can implement symbols and the symbol for method and method also a function because it's in an object. I'll call it a method and symbol iterator and symbol species. We've seen how we can use it, but unfortunately, we had an error that is supposed to return false in the symbol species class, but returned true. And then we'll figure that out soon. So if you have any questions, you can go ahead and ask. And if you don't have any questions, we'll meet in our next class. So thank you, and drop your questions on Discord so we can discuss over there.